All right, everybody. Numeric response number 6. It says if g of x is equal to, and I give you the function there, the x-coordinate of the local minimum to the nearest hundredth is. Okay, well this is an interesting question because it's a cubic. So I'm going to have a maximum and a minimum here, a local maximum and minimum, I think. Okay, I think. I don't know, but that's what your basic cubic looks like. You think back. Okay, cubic kind of looks like this. Now, actually, I should erase this. I want you guys to be clever about this. I mean, there are things that we can do in calculus, but I want you to be clever about this. This is a cubic with a positive leading coefficient, meaning that it should look something like this. Okay, meaning that, and the reason why I bring this up here, and I'll verify this in a different way in a little bit here, but I'm going to have a local max and a local min, and notice that the x value of the local min should be larger than the x value of the local max. Okay, so I'm going to end up finding two x coordinates here. I am very likely going to be choosing the one that's larger. And I know that because I already know something about the way that function looks. But we're going to verify this in a different way here in just a second. But anyway, that's okay. There's a few things we could do here. G primed of x, obviously I'm going to have to take the derivative. It's calculus class. So that's going to be 24x squared minus 6x. Okay. I am going to set this equal to 0. What I've got here are just two terms. Notice that we've got this common 6x here, so I'll take out the 6x and I'm going to be left with 4x minus 1 is equal to 0. So my two possibilities here will be x is either equal to 0 or x is equal to positive 1/4. And I suspect that my local minimum will occur at positive 1/4. Now, a couple ways to check that. Okay, first of all, I already have a sneaking suspicion based on what I think the diagram looks like. But let's just check the intervals of increase and decrease. Okay, we've got 0 and 1/4. The derivative is a parabola that opens up, so it's going to look like this, meaning that it's positive here, negative here, positive here, which means this is increasing on the interval negative infinity to 0, and then 1/4 to infinity, and it is decreasing on 0 to 1/4. So looking over here, I can see it's decreasing to 1/4, increasing afterwards, which definitely makes that point there, that point right there, that x-coordinate, our local min. That's one way of doing it, okay? Or we could do it like this. And actually, this is the way that I would normally do this because I'm super lazy here. I'm going to take the second derivative, okay? So I'm going to take the second derivative of this, and that's going to end up being 48x minus 6, okay? And I'm going to end up plugging in that critical number. So the second derivative evaluated at 1/4 is going to be, well, 1/4 of 48 is 12, minus 6 is 6. And because that is positive, I know that it's concave up at 1/4, and that tells me that I've got a minimum. So therefore, the x-coordinate is 1/4. That's where that local minimum is coming from.